Okay, and we talk about these types of generators. Your lab you've already had, or you will have, the series generator. Types of generators. You've got the series generator, the shunt generator. Okay, we'll be working with two different types of shunt generators. Self-excited and the separately excited. We're going to be going over both of those tonight. Okay? This is made up quite a bit different from the series generator, and we're going to go into those differences. The other generators we have are the compound. All right? Compounds are made up of combination of shunt and series. Okay? Now the term series refers to how you connect up the winding relative to the armature. Remember when we did the series, we had the winding in series with the armature current? Okay? So you have the series field wired in series with the armature. Make sense? Yep. Okay, shunt. What does shunt mean? Parallel. An alternate path, right? So the shunt is going to be wired. The shunt field is going to be wired in parallel with the armature. The name of the generator tells you how to wire it up. Okay? Compound. We have a series and a shunt winding together in the compound generator. So where do you think you put the series field? It's series with the armature. You put the shunt field in parallel with the armature. And we have three different little combinations of this. We have the long shunt, short shunt, and the differential. These are all the generators that we're going to cover here. Okay? So, go. Let's see. What I'll do is I'll real quickly throw up the series generator for a review on that, and then we're going to drop into the shunt. Okay?
Quick question.
Sure.
Would you quickly explain why all this? Why not just one type of generator and done with?
As we get to the characteristics of the generators, you'll see the differences. The shunt generator is really inexpensive to make. You've got an armature and a shunt field. Very simple to make, self-excited. VW generators for years are just shunt generators. Okay? Their characteristics, as we're going to see tonight, suffer. And one of the things when we start talking about compound generators, if you want a better performing generator, you add in these other components. Okay? Those components drive up the cost. And so you have to look at a cost-benefit analysis of, is this going to do okay for us, or do we need other things?
Your head is getting...
My head is getting caught off. Okay, so I'll stand back here so my head...
Have him just...
No, you don't see me anyway. It's the material, right? Okay, so I'll stand over here so my head doesn't get cut off, okay? You just hear me. Okay? So let's talk about the line ladder on the series generator again. Okay? Is everything on there fine?
Yep.
Okay. Now, we've got our generator connected up with our armature and our series field. These are in series. Now, we have our switch over here and our load. Put our amp meter there. In this case here, your output voltage is across that point. Now if you remember with our line ladders, you put your power supply up at the top, your load at the bottom. Your switch is on the left, your load's on the right of those rungs. Okay? So when you're coming together and putting this line ladder together, what is your power supply here? It's a generator, right? So the generator sits at top. You will see in the book, you will see other places, they'll put the generator down here, your load's up here. Let's try and stick with the convention. The power supply on top and all of your loads and control down at the bottom part. Okay? This part here where I have the voltmeter is the dividing line between the generator and your loads. If I want to put another load on here, put it here. Now if you remember, our voltage starts off, and what do we have in here to start our voltage off? The residual magnetism? All we have in here is residual magnetism when these switches are open. So our voltage starts off near zero. In the lab, were you finding that the voltage was around 3 volts?
Yeah.
Okay? So we would start around 3 volts, and as you add more load on here, our current went up. We have more current through the coil. Our magnetic field increases. Our voltage goes up. So in this case, our series generator, our output voltage is dependent upon the amount of current. Right? Good? What kind of questions do we have on the series generator? Those of you that had the lab already, did you see the voltage curve? You guys put your curves together? Okay? It started off, okay, you might want to turn this. Okay? You started off, you have volts, amps, and it should have started off around here, around 3 volts, and went up something like this, right? I saw a few curves where it started coming back down again.
Yep.
That's good. That's okay. All right, we'll talk about that a little bit tonight as far as how it happens with the shunt generator. Okay? So this is what we had. We had no discontinuities in here, no large jumps. Nice smooth curve up there, right? Okay? Go ahead and hit the stop.